Hi everyone, this is Sangeeta working as Assistant Professor in IoT Department, SNS College of Engineering. This session I'm going to discuss about media access. So in that, it is also under a physical layer. So multiple devices using common medium, there will be a problem of using the channel at the time. If multiple stations are using the channel simultaneously, there will be a problem like a collision occur. Due to that, the data may get lost. So for avoiding that, we have to allocate the channel for the station to transmit the data. So in this session, we will discuss various medium access techniques one by one. So normally the data link layer divided into two functionally oriented layers. One is data link layer and multiple access layer. So in this, the multiple access protocols are different category: random access protocols and controlled access protocols and channelization protocols. Likewise, it's categorized into three. So in that random access protocol, we have different access mechanisms like Aloha, CSME, career sense, multiple access, career sense, multiple access collision detection, career sense, multiple access collision avoidance. And that in that controlled access protocols, reservation based, polling based, and token passing based. Then channelization protocol, frequency division multiple access, time division multiple access based on code division multiple access. So likewise, different multiple access protocols are there. In this session, we're going to discuss about random access protocol. What is random access? So in random access or conduction methods, we can also call no station is superior or is superior to another station and none is assigned as the control over the another. So no station permits or does not permit another station to send. So each instant, the station that has to send the data based on the procedure defined by the protocol. So before transmitting a data, it must take a decision on whether to send or not to send. So the random access methods are Aloha, career sense multiple access, collision detection, and collision avoidance. So first we have pure Aloha. In that, if we consider, there are four stations: station 1, station 2, station 3, and station 4. So each station transmitting frames. So if the station 1 send the frame at frame 1.1, that time the channel is idle. This entire capacity of the channel utilized for station 1. At the second time, the station 1 is also send another frame. Station 2 also sending frame. Station 3 is also sending frames. Station 4 also sending frame. In that, the channel will be occupied by the four stations. So due to that, there is a possible for collision here. So this duration is called collision duration. So then second time slot also after frame 2.2 and 4.2 of station 4, that also the frequency of collision occur. So in that time, we have to sense the medium before transmitting the data. In that procedure for pure Aloha, first start with that, send the frame. If the waiting time is okay, the data will be sent. If we receive an acknowledgement, it's successful. If not, we have to resend it again. Otherwise, there is no acknowledgement received for the accepted time. The transmission will be aborted. Then slaughter Aloha, the time will be divided in for each station. Each time slot, the station can use it. So we can, in that division of time slot, we can control the data transmission of each station. So here also there will be a possible of collision if the multiple stations sends the data simultaneously. And here behavior have the data transmission behaviors are categorized into three persistent methods. So one persistent, non-persistent, persistent. In one persistent method, continuously sensing the medium. If it is busy, have to wait. Otherwise, the data will be transmitted until the channel gets idle. We keep on checking whether the channel is busy or free. So this kind of persistent method is one persistence. If it is a non-persistent method, if check the channel, whether the channel is busy, have to wait for some duration. Again, after some time, again it check the channel. If it is free, it can use, otherwise have to wait. So likewise, it's a non-persistent one. And third one, P persistent. It's also continuously sends the medium whether it has a busy cycle or idle, and it have both based on slot. The time slot will be allocated to sensor medium. If the within a time slot, if allow the station to send, it can send. Otherwise, have to wait another time slot. This is P persistent. Different persistent methods are used in Aloha. And this is the diagram. Check the channel. It's a busy. Have to wait. Otherwise, if it is an idle, station can transmit. And that non-persistent random time duration have to wait. If it is busy, have to wait. Otherwise, it's idle. The station can transmit. In that method, another one method, channel is busy. It have to wait. Otherwise, idle means check the probability outcome. It's wait for time slot, and channel again check. There's a busy. Use backup process again, and the collision through the collision occurred. If it is idle, can say. So likewise, the transmission will be takes place on Aloha. Then this is the flow diagram of Carey-Sense multiple axis collision detection. So normally it is used in wired environment because we can detect where it occurs. If it is in wireless environment, we cannot predict where it occurs. So that wired environment where we can able to check whether the wire gets damaged or collision detected. So this kind of method, check the start with that and apply on any one of the persistent method. If it is an idle, can send. Otherwise, have to wait until the channel gets free. So based on sending jamming signal, can identify whether the channel is idle or not. Then CSMA by CA, this method will be used in wireless environment because in wireless environment there is no physical wire, so we cannot detect where it occurs. So before instead of detecting the collision, we can avoid it in wireless environment so that CSA member CA most probably used in wireless, mostly used in wireless environment. So this is a flow diagram of CSA member CD and CSA member CA. That's all about medium axis. Thank you.